Hey everyone. How's the sound at the back? I guess you can hear me all right? I'm assuming so. People at the last row, can you hear me? Great. Hi everyone, my name is Awa, and today I'm here to talk about variance of proof of stake. I forgot about the clicker. So just to give a little background of who I am, for people who don't know me, I'm one of the co-founders of Crypto Labs, and before that I used to be a researcher at Cosmos, and before that I used to be a data scientist and software engineer at Chainalysis. So you understand a little bit the perspective I'm coming from. Crypto Labs is a proof of stake validator. Our goal is to become a validator for any reasonable and public networks that rely on proof of stake. By reasonable, I mean that they use a variant of proof of stake that actually has something at stake. And by public, I mean that it is, let's say, arguably easy for any entity or any peer in the world to become a validating node. And interesting enough, when you apply these filters, and then plus you look into like actual active testnets and or systems already in production, there's really not that many protocols that apply, right? Yeah. So as a company, we're fully based in Switzerland, and since last summer, we started to work a lot on community development. That means in learning about these protocols and then also writing content, explaining it to the diverse blockchain community and then how they actually work so they can understand what are the economic or security implications at their end. Which is why you will see that my talks are generally very lecture-like, more like informative as opposed to more opinionated. Recently, we've moved towards protocol development, but still, we're going to continue try to explain to more people about different protocols. So the agenda I prepared for today clearly separated into two blocks. The first block is, again, informative. The second block is more about me sharing some experience and me sharing some reflections around the experience I gained as running validation services professionally. So the first part, we're going to start by revisiting some basic concepts, and you will see later on what I mean by revisiting. And then we're going to look into some variants of proof of stake, mainly 4 of them, although there are more. And then comparing 3 of them, first of all, with the consensus layer. So what choice of consensus algorithms they build a system on, which later on is important because that heavily influences on how you design the economic model behind it. And then I will share a little bit about how I view some challenges that I think protocol designers will face in the future. And then if we have time, I'll open up for questions and answers, normally the most useful part. Okay, so let's start with revisiting some basic concepts. So first of all, consensus algorithm does not equal to proof of something. And this honestly didn't matter until recently because all the networks relied on proof of work, right? Most of networks in the space of public blockchains work proof of work. So there was no need to distinguish between these two because proof of work came also inherently with Nakamoto consensus. However, to make your lives easier in the future, because you will see that I generally suggest that you clearly differentiate between these two concepts because they're actually not the same and that they cannot be used interchangeably. So consensus algorithms are broadly defined as mechanisms that enable trustless peers to agree on a specific state values. And the state values could be, let's say, data structure like a list of transactions, a block. It could be something else. Whereas proof of something is, I would say more correctly, defined as those mechanisms that determine which peers are allowed to participate in consensus. So in other words, which requirements do you need to satisfy in order to become a validating peer in a network? So two major families right now of consensus algorithms is Nakamoto consensus, pervasive in all proof of work systems. Nakamoto consensus is actually a very simple consensus algorithm. It simply states that the chain or the chain that has the largest pool of work or largest pool of consumer electricity and such is the canonical one. Very simple. Now, after around 2014, 15, there started to be a new family of consensus algorithms started to be explored. I call them the family of Byzantine fault-tolerant consensus, which is inspired from decades of exhaustive research into distributed systems, so classical computer science research. And The different variants you will see later on, but what they have in common is that the way they determine consensus is as long as 2/3 of the validating set agree on that value, then this is finalized. It's just a different way of agreeing. So two main families of proof of something algorithms, right? Proof of work is, in order to participate in consensus, in order to earn the right to produce the next block and earn the rewards, I need to compete with other peers and solve the computational puzzle before. In proof of stake, again, there's like a lot of different interpretations, but what they have in common is there's this basic idea of if you want to participate in consensus, you have to allocate a certain amount of wealth or value as a collateral. So if in any case you deviate from the protocol, that amount will get slashed. Interesting enough, with the introduction of different interpretations in proof-of-stake research advances, the nothing at stake problem appeared. So nothing at stake problem is a characteristic that certain variants of proof-of-stake systems have. And the basic idea is that nodes in consensus nodes in proof-of-stake, they can simply generate as many forks as they want, and they can maintain them in the future at basically no cost. So in proof of work, this wasn't an issue because you had to point to the specific chain you want to build on your hashing power. So which meant that if I wanted to maintain different forks, I had to scale my infrastructure horizontally, right? I had to add more hardware and so on, to validate more, to mine more on different chains. But in proof of stake, creating the basics of the work that validators do is simply creating the signature, the digital attestation, right? That later gets broadcasted, which is really cheap to compute. So an example, or classical example that you give on where the nothing at stake problem is present is, by the way, is present in other projects as well, both in academia, both in commercial projects. This is the example I typically give, which is delegated proof of stake, using by protocols like EOS. The basic idea behind delegated proof of stake is that a block producer will not get voted again if it misbehaves. Right? So let's say I'm a block producer in year 2021 and then I cheat. I would just simply not get voted again, and hence, arguably, I have my reputation at stake. But I wonder if that's a fair assumption because it really depends. There's no notion of stake in delegated proof of stake. That's first of all. There's no slashing conditions. There's no allocation of wealth as a collateral. And the other question is there a notion of accountability? And I, as a stakeholder, can I prove or can I first even detect that any node is misbehaving? Just some food for thought, let's say. So I guess here, how many of you are dApp developers, actually? Could you raise your hand for me to get a sense? So, okay, cool, thank you. So I would say, especially in the Ethereum community, generally the sentiment is that security, you don't have to worry too much about the security of the network because Ethereum will provide it. You simply build on top of it, and that's fine. But I would say care about your security if you're thinking into looking into different platforms as well as, for example, scaling or looking for something that fits better the security requirements or liveness requirements of your application. I would say care to an extent where you see it as a necessary thing, but of course you would care a lot more about, you would first build your application better because that's where your competitive advantage lies, right? An example I like to give that is outside of blockchain world is, let's say if you're a game developer. I really like playing multiplayer games. I don't play League or Dota because I know that infrastructure is extremely secure, right? Although they might have most resilient DOS infrastructure against DOS attacks possible. I play because I think it's fun. So you as a dApp developer, you might want to prioritize that over security. But what happens if I find out one day that League or Riot Games or Valve has been cheating behind and actually the ranking system was not fair? Then maybe at that point I will actually care, right, because that's a necessary point to make your game fun. Just an example. Another concept I want to review, which might seem Like depends, I think a lot of people just like assume this. But another novel thing about proof-of-stake systems you will see is that they will split between the block production mechanism and finality mechanism. So which again, in proof-of-work wasn't necessary, everything was in one, right? But now with the new variants, we're starting to see that you can have one system that produces the blocks, that advances the chain, and another one that finalizes them. And this is where finality gadgets come in. So finality gadgets, for example, Casper, FFG, Polkadot's AFG, and such, you can have an underlying chain that produces the blocks, and then you can have an additional chain or even an overlay on existing chain to produce finality. So again, now we're going to go to some variants of proof of stake. So like by no means there's a lot more than this. So I just chose them because I thought at this moment people were more interested in this, but there's more than this. So some variants are liquid proof of stake, which is used by the protocol Tezos, for example. Bonded proof of stake is used by Cosmos, and any chain that is built using the Cosmos SDK, like IrisNet. Nominated proof of stake is the variant that Polkadot will be proposing, and Casper FFG is the beacon chain that Ethereum 2.0 is working on. And you can see that we have, first of all, the economic model on top of it, but they can couple with different consensus mechanisms. Actually, Tezos, although it's proof of stake, where there's actually something at stake, uses Nakamoto consensus for block production and also for consensus. Whereas bonded proof of stake is going on full tenement, so they are using BFT consensus. And nominated proof of stake in Casper is kind of like a mix between both. You can use underlying block production system that relies on Nakamoto consensus, and yet have an additional gadget that provides finality that could be a variant of proof of stake, of Byzantine fault tolerant systems. So let's compare them first at the consensus layer. I actually left out Casper because I'm sure you can find people who can explain better than me at this point. And I think it's important to understand a little bit the consensus choice because that actually influences a lot on designing the economic system behind it. So first of all, Tezos. Tezos uses Nakamoto consensus. Nakamoto consensus is very simple, like we've seen, it's pervasive everywhere you see, very simple. In Tezos, validating nodes actually have two tasks. It's not only in producing and validating blocks, but also in generating endorsements. Endorsements are simply this operation of, I've checked a block at this height, and I say, this block looks good, like I validate this block. So it's like an additional attestation. And considering the network could be partially synchronous, there's a chance that when it's your turn to validate, you have to choose which chain, because there could be temporary forks that are generated. It's simply because there's some latency in the network. And then at that point, what you would do is you would choose the block that comes with the precedence that have the highest amount of endorsements. So it's like simulating, it's like simulating proof of work without having to do the mining part. In Cosmos, which I'm really excited about because I think a lot of people are not realizing this, but to date, there's no network yet that is using BFT consensus. Up to date, there's besides Iris, but up to date, all the networks rely on Nakamoto consensus. And Tendermint is going and say, we're only finalizing, so we're producing blocks using the same system, and we're only finalizing them as soon as 2/3 of the validating network, of the validating set, have provided that attestation. So if 2/3, if not enough are online, we're just gonna wait. And then eventually, hopefully they will come online, else they will get left out from the consensus set, and eventually we have enough threshold to continue the chain. Else we're just gonna hold the chain. Polkadot, which is working on, so people call this grandpa or shaft, and I categorically refuse to call it like that. I call it Owl's finality gadget. My preference would say. So Owl's finality gadget, on Polkadot, there will be underlying block production system, most likely relying on a variant Nakamoto consensus. And then there will be the task there will be another task for the validators in the relay chain, which is to produce finality. In this case, due to network asynchrony or due to network latency, you will be able to, when it's your time, you will have the task to vote on the block, but the block, you're actually voting on the prefixes because the block comes with a set of ancestors, right? But then what happens is that you might be voting for blocks that had different ancestors, but then in that case, the ones that get finalized are only the ones that are actually common in 2/3 of the network. So let's say in this case there are 3 forks, right? But the ones that are common in across all of them, it's only 0 and 1. So I'm just going to finalize those at the moment and let the chains go on, and then eventually there will be more common ancestors. So I'm going to finalize those. So there's a gap for probabilistic finality in between them. You might have realized that under the assumption of perfect networking conditions or network conditions, actually both Tezos or both Polkadot will look so the progression of the chain will actually look very similar to Tendermint. Just an observation I had when I made the graph. So, comparing economic models. This is also a very flash way, I'm trying to be very quick in explaining how Tezos works and in the proof of stake of Tezos works and other networks. So I'm going to be skipping some technicalities. So in liquid proof of stake or in Tezos, if you want to become a validating node or participating consensus, there's a minimal requirement of you have to allocate 10,000 XTZ as a collateral. Actually, this number might change in a few weeks. Currently, there's an on-chain governance process ongoing when people are still voting on it. So somebody proposed to change that value to lowering. So maybe we'll change in a bit. The reason why people want to become validators on Tezos or bakers is because they get to earn the portion of the annual inflation of the network, and that's currently at 551% in the best case. And the way they get to so how do they choose who gets to produce what block or who makes endorsements, right? And the way they do it is they use a system that's basically a random system that is based on how large your stake is. And stake is both your self-bond, so the amount I put at risk, plus delegations, which, by the way, are not at risk. In the case, another operation that the liquid proof of stake rewards for is in accusing other people. So let's say at some point, I am a validator, and at some point I received 2 blocks that are actually at the same height, but they're different, and they were signed by the same validator's keys. I'm just going to include an evidence into the network and broadcast it. And then that node that made that committed that safety fault will get slashed. And in that event, me, who submitted the evidence, I will receive 50% of the entire amount that got slashed. And the other 50% will get just burned and disappear from the entire supply. So what happens to the peer who committed a safety fault? So that peer will actually lose, in the worst case, there's some particularities in there, but in the worst case, it will lose the security deposits of the entire cycle. Cycles the way they measure time in Tezos. And that is the amount in security deposits is proportional to how large you are, how large your staking balance is. So the larger you are, let's say, then the more you get slashed, basically. And the liveness is actually not penalized directly. It's simply if you, your time to produce a block or sign up for a block comes, and you're offline for whatever reasons, then you will simply not win the rewards, but that would not influence your future likelihood of being elected again or such. In Cosmos BPOS, bonded proof of stake, in order to become a validating node, I need to rank top 100 by economic stake. So I need to have enough of self-bond plus delegation to rank on top 100. The way you assign slots is very similar to Tezos in practice, which is simply the higher amount of stake you have in proportion of the network, the higher the likelihood of you being the one who will get elected to propose the next block. What is interesting in Tendermint, in Cosmos, is that they're experimenting with the idea of adaptive inflation. And inflation in Tezos is about fixed to about 551% annually fixed by the way they introduce the rewards and by blocks and such. But in Cosmos, they're looking into, let's make it adaptive depending on how much is globally at stake. So let's say 100% of the network is of the total supply of atoms are at stake, then the value, the inflation would tend towards 7%. But if the globally amount at stake is towards, tends to 0%, then the inflation will be capped at 20%. But it would tend towards that value, so the higher value. Is it something interesting that Tezos did not consider? So there's also a similar system for like you can denounce other people, but in this case, whereas in the case of Tezos, the one who denounced got 50% of the rewards as a reward. Here, although you denounce it, 50% will be burned, but the other 50% would just be scattered across the entire validator set equally. So for slashing, this is very interesting. So in Tendermint, they prioritize safety a lot. So one safety fault will get your entire 5% of your entire staking balance slashed. 5% is both includes delegation. So like I might become validator in Cosmos and have my own atoms at stake, but I might receive delegations as well. But in the case of commit a safety fault, the entire thing will be indistinctly slashed. And there's another thing, which is you get executed. So you cannot become ever, so your keys, the ones that you use for this validator, you cannot use them ever again. They cannot pop up ever again into the validating set. So you drop out of consensus forever. You will just have to generate a new set of keys, that's it. And then the delegators will have to figure out basically who else to delegate, or maybe never ever delegate, I don't know. So there's another thing, which is different from Tezos, is there's like slightly harsher punishment for liveness. So let's say I haven't produced a signature as a validator in Cosmos for the last 24 hours. In that case, I will get jailed. Jail means that you drop out of consensus, but you can come back again. But you will have to drop out of consensus for 7 days, which means that you're missing out on the rewards you will receive otherwise. So Polkadot is in NPOS, is still under construction. This is just some features that I thought were interesting to share that were different on the other networks. But again, there's a lot of moving pieces in NPOS, so like better ask the researchers and see what's going on. So a thing that I thought was really interesting in NPOS is the fact that in Cosmos and in Tezos, it is the task of the delegators to do the research and like choose which validators they should like delegate to, right? And then it's like their responsibility to do so. Polkadot comes and says, I think what we're gonna do is we're gonna build an algorithm that does this automatically to maximize for the global amount of tokens at stake. So what you as a delegate, what you do is you actually submit your preferences. So you say, let's say, I prefer these 4 validators, and then also this is like my risk scoring versus like reward scoring. And then the algorithm will figure out, and the purpose is to actually have a uniformly weighted set of validators, which in the case of BPOS and LPOS, everything is ranked by stake. So like people who are more stake have more voting power. Another thing they're saying is that not only validators can submit their evidences. If you are not a validator, but you are monitoring the network and you realize, hey, this node doesn't seem to be like, it seems like they cheated, you can also submit a transaction and you can claim rewards in return. Just like maybe an improvement. And then another thing about it is that up until then, they were normally, so in NPOS, they're thinking of the idea of getting the validators token slashed first before getting the ones that the delegators slashed, which in the other networks is like, it's indistinct. In Tezos, it's not as, delegations are not at stake, but in Cosmos, validators and delegators are just equally punished. They're also looking into differentiating between what are correlated faults and what are uncorrelated faults. So the thing is, if you watch Adrian's talk yesterday, there's actually a lot of like, it's actually quite easy at the moment to, if you don't have enough the right tools, to commit safety faults accidentally. Because like something around managing nodes, and then you had a automatic failover system, something like redundant systems, and all of a sudden accidentally you spawn two nodes that were valid under the same keys, and then you double sign, right? So Polkadot is coming and saying, if it's like evidence that is uncorrelated, so this might happen, you accidentally do, but there's no thing that it was like a coordinated attack, then we just get slash 1%, which is meaningful or not for people to question your security, right? Or your, let's say, your managerial skills on the validation service, but not that large as where in Cosmos, which like entire 5% gets like lost. But in the case that there is evidence that a third of the validator set is coordinating the safety fault, then your entirety of the entirety stake of your stake will be slashed for the entire set of like third people correlatingly committing safety faults. Interesting to like look into. Another thing I realized is when I was making especially this table is, so Tesla's actually built a system, they designed the system around 2014-15, so they actually did not include a lot of ideas that came out after. Cosmos hopefully will go live next week. But if you look into, like if you progress, and Polkadot is not ready yet, right? If you progress across time, you will see that the systems grow in complexity, right? They're trying to look into different things that they didn't consider before, and they try to see, okay, this is what you're trying to do, but maybe we should do it this way because otherwise it might have another side effect. Just a reflection I had. So what is better? I don't know, and I can't tell like what is better. I think what matters is that, which is something that I think some communities are a little bit oblivious about it, is that there's a lot of platforms out there. And everyone is going to tell you, we're going to be comparing the other ones, and ours is better because of that and this. But I think if you're application developer, you have your own project, you're responsible for your project. You will have your users, and I think it's worth actually try to take a little bit the objective view and do a little bit of research, and actually seeing which platforms fit more on the core value of of the application. So let's say security is highly important. So maybe you're willing to sacrifice a little bit liveness for safety, and then choose, maybe then in that case, Cosmos is better. Or like, maybe that's not the case. Maybe you prioritize, maybe you're okay with not having finalization of blocks, and then just assume that risk, but they still have always ongoing transactions, right? So I can't say, but here are some platforms they can look into. Here are some platforms that come with different trade-offs, and I think it's worth looking into it. So some challenges for proof-of-stake researchers that I'm foreseeing is that, so I think that proof-of-stake is again, like not like in proof-of-work, proof-of-stake is an area of research where you can actually add a lot of complexity to your systems. And I think what happens a lot is that there's a big difference between what in theory works and what happens in practice. And that discrepancy can come from things like you did not consider all the edge cases, right? Or you did not, people often forget that building blockchains is harder than writing papers, but that's actually true. Building a blockchain from scratch is actually a very complex task, and you have to think about a lot of things, especially in proof of stake, which is like a new area of research, right? But I think what's most risky to do as a protocol designer or researcher would be to simply be oblivious to the incentives of validators. So simply not considering them and say, they will figure out like whatever. Because in proof of stake, validators are in charge of the security of the network. It's like, if I want to compromise the network, I'm going to start attacking the validators because they are in charge of securing the network, right? So you need to understand, you need to take into account a little bit, like who are they? Why are they doing this? Is it purely for profit? Do they care about safety at all? And like, how are they funded? These kind of things. They might seem trivial, but they're not, because you have to think about this long-term survival of your network. So just a little bit for thought. And another thing is, they want to remind all of you, is the goal of proof of stake is to become an actual substitution of proof of work. And you want to do it in a way where you actually, so the goal is to not trade off some externalities like environmental impact or like unnecessary use of scarce resources like electricity for security. But it's still a lot of work to be done in both research and implementation. And I would not, I generally would say that a lot of these networks that will launch, they will actually not be perfect in the very beginning. Then there's still a lot of room for researchers and people to work on this together. So I don't know if I have time for questions. Do I have time? Okay, I don't have time for questions, but I'll be out here if you have any, and just catch me after. Thank you.